welcome back. If you've been following the video up to this point, you'll know that I've encountered some technical difficulties. Basically, before I started capturing the last video, I had made some minor adjustments to the code, which I didn't think were that major, but apparently they did cause some issues. In particular, one of the issues we had was if when the timer was running out, if I pressed the button indicating that I knew the answer, if I pressed it right before the timer ran out, like on the last second, it would say correct, but then it would still give me a game over. So that was one issue. I've corrected that. Also, I had neglected to output the score, which I noticed during the video. It was just something I had taken away when I was doing something else, and I was trying to do some troubleshooting. So I've corrected that issue, so now the score will be output if you lose, and it will give you the current score of what rounds you successfully completed. Also, I changed some of the functionality of the hint button. Instead of just toggling continuously through the hints, I now have it if you press the hint button once, it shows the category. If you press it a second time, it shows the first letter of the word that you're trying to guess. If you press it a third time, it shows an anagram or a scrambled up version of the word. That's all the same as before, but before, if you press the button again, it would toggle back and show the category again, and then the first letter, and it would just keep going through the hints. Now if you press it a fourth time, after you're on the scrambled up version of the word, you'll come back and see the original word again. And then you'll start cycling through the hints again. Category, first letter, scrambled up version, back to the word. But everything else should be the same. As the timer's running down, correction, I did change the timer. I made it 25 seconds now just so I can have a little more leeway. But as the timer is running down, the RGB LED will change from green to red, and it'll smoothly transition throughout the 25 seconds. If I lose, I'll get a game over in the score, and I'll also hear the sound that's the theme from Mario when Mario falls in the lava, so just a negative sound for the fact that you lost the game. If you get a correct guess, you'll get the sound of Mario completing a stage. And if you win the game, you'll get just the Mario theme. As well as the countdown's happening, you're going to get kind of like the Jeopardy tone. It doesn't sound perfectly like Jeopardy, but it's pretty good. And I got the code for the Jeopardy off of someone offline, which I've referenced actually in my comments, I believe. But yeah, that's pretty much it. So the code should still run as normal. We'll do a quick run through again, just showing you the circuit demo. Again, when the timer is almost running out too, the vibrating motor will shake. I've put it on this felt mat so it's not as violent, but that's pretty much it. Let's give it a run through. And just to show that this is portable, again, you can use a battery pack that hooks in through the barrel jack, or you can use a portable USB charger, either or. So alligator, I'm going to press the hint. That's an animal. First letter A. This is a mixed up version of alligator. And when I press it again, I go back to showing the animal. And then toggle through the hints again. You can see the RGB is almost fully red now. We're shaking. And if I press, even the last minute, it's correct. And there's no game over. So this changes from green to red as the timer runs out. Again, I can cycle through all the hints, 3 hints for each, the last one being a mixed up anagram, and then go back to the word. As the time runs out, this gets close to red, and this will start giving us haptic feedback. And we get the Mario stage clear sound. If we get a correct guess, we get the Jeopardy sound going as the timer's going. I'm just going to say correct guess a couple times. Again. And let's win the game. There we go. If I was to and we'll flash green 5 times if we win the game, 5 times red if we lose the game. Let's try again. We're just going to lose right away. But and then we'll finish the demo with it working correctly. And then we'll move on to the code. Almost fully red. I'm about to get haptic feedback. And we're about to lose, and I'll show my score. No, score 0. I realized I didn't do anything that time, so I had a score of 0. So we'll do it one more time to actually show that it does keep track of the rounds you've won. So that's 1 round. I'm on round 2 now. I've won. Round 3, I've won. Now when I let it go down the timer, I'll lose, but the score will be 3. Because that was the last successful round. Because I'm not successful in round 4 if I lose. Again, I can get my hints. And always come back to the word. The RGB LEDs changing color, getting closer to red, and haptic feedback will be showing up. So Mario falling in lava is the sound. We're going to flash the RGB LED 5 times red and show the score. So code's working, but now let's actually look at the code. So, as usual, I'll try to go a little quicker through this because it's already been a long video, but I'll still try to be thorough. As always, if you have questions, post them on the forum. I'll be happy to answer them. So, I like using Doxygen comments. I've showed that before. It's basically a multi-line comment that starts off with a / asterisk and ends with an asterisk / That's the standard multi-line comment. However, if you add an extra asterisk on the opening, it turns into a Doxygen style comment. Basically, anyone who's done Java and is familiar with JavaDocs, it's kind of the same thing, but it basically allows me to put my code through an external program, like Doxygen in this case, and the program will make some really nice professional looking HTML pages for me, detailing my code and the functions and everything if I use these comments in these special little tags. So @file, which is the name of the file, which I don't think I've changed yet. I always put the name that I'm going to keep at the end in here, but I've got so many names in the meantime as I'm coding. And @brief always describes what it does. This is a DIY heads-up game with LCD, RGB LED effects, haptic feedback, that's the vibrating motor, and sound. @details, it's a little more details. This program implements a custom version of the popular heads-up game using Arduino. Players interact with the game using buttons, and the system provides visual feedback via an RGB LED, sound effects using a buzzer, and haptic feedback via a vibration motor. Additional features include a countdown timer with RGB LED transitions from green to red as the timer runs out, a hint button, button to provide clues for the current word, sound effects for countdowns, correct answers, and timeouts, i.e. game over, and those are the Mario theme sound effects. Except for the countdown, it's Jeopardy, and modular design with reusable functions for improved maintainability. I'm the author, this is the date that I'm putting out the code, and I said version 6, this is probably version 20. I end up saving the code a lot because I had a couple times where I didn't save the code and it was a lot of wasted time. This is the hardware. I thought this was a tag, but it doesn't seem to be highlighting, so I'm not really sure what's going on there. This just shows kind of how you'd hook up the thing. So SparkFun breadboard, you're going to need that, which is generic Arduino microcontroller, an LCD with these pins, an RGB LED hooked up to these pins, a couple push buttons, again one push button for the next word button, the correct guess button, the black one, and another push button for the hint button. You'll notice I'm using A3 as my button. I think I went over that in the last video. You can use the analog pins as digital pins if you need to, and I needed to because I ran out of room, not because of this circuit, but because I've got other things hooked up that I didn't want to take apart. Piezo buzzer on pin 7 and your vibration motor on pin 4. Just ensure that you have proper connections, and I included this because the Jeopardy code that I'm using in particular, the theme, came from this guy, Tom Igo, sorry. I'm probably murdering that name, but my apologies. He's put this code up and it said for public use, so I used it. I also found the code for the Mario themes on GitHub. There's lots of different versions of Mario is pretty popular for Arduino, so that's why I used it. So going through the code, I'll try to go somewhat quickly, but again, I'm going to also try to go in enough detail that it's not just blazing through the code. But if you have any further questions, post them on the forum. So as usual, I've included the liquid crystal library. That's so I can use the LCD, and I've included the pitches.h header file. And you'll notice the difference. The liquid crystal header file is in angle brackets, and the pitches header file is in double quotes. Well, that's because the liquid crystal header file is a built-in C++ header file, kind of like within the language now. Whereas pitches is just a header file associated with kind of a user-defined one. And what it does is it has the constants for the frequencies of various musical notes that I'm using. It's fairly common to use if you're using different melodies and functions to include this header file. I've got a bunch of define statements. So for my RGB pins, my red, green, and blue pin associated with my RGB LED, they're all PWM pins as required because I want to have varying levels of red, green, and blue displayed on my RGB LED for smooth transitions. I've got my two buttons, my hint button, which is on digital pin 2, and my game button pin, I called it. It's the button you press when you've got the correct answer. That's on pin A3. Again, it doesn't need to be an analog pin. There's no analog output. There's no analog input. I'm simply using it as a regular digital input pin for a button. I just ran out of digital pin, so I'm hijacking an analog pin. The buzzer is on pin 7, and the vibration motor is on pin 4. So if you've watched previous videos, sometimes I go back and forth between using the hashtag define style, which you use hashtag define, the name, and then just the number of the pin. There's no equal sign or anything like that, and you don't terminate with a semicolon. That's kind of an older C style way of coding. The more modern way would be go something like this, const int, and like for the vibration motor, you go vibration motor. So same syntax, all uppercase, is kind of conventional, and you'd have to go equal 4 and do that. So that's kind of the new modern way to create your constants, using the const keyword in front of your variable as you're used to doing it. I go back and forth between using this style and this style. If this was for production purposes, I'd be consistent and I'd use one style, most likely this modern version. But for educational purposes, I like to go back and forth just so that we're being exposed to as many things as possible. So that's that. These are just my constants. I've created my instance of the liquid crystal library, basically initialize my LCD with the control pins. Sometimes I use constants for these, but in this case I haven't. So these pins just are associated with the RS pin, the register select pin, the enable pin, and the 4-bit data transfer pins, as you can see by the ID that's popping up there. This is kind of the original code that came in the circuit from the 4C circuit code from SparkFun. You have an array of size 25, all these animals names, and the category is animal for all of them. I only changed one of them to comp44, and it's an AU course. Obviously, if this was a game, you would have a lot more than 25 words likely, and you'd have various different things. You'd have some animals, you'd have some objects, maybe some actors, and you would, as long as the index of your word matches the index of the category, you can do whatever you want. That's not really the point of this video demo or anything, so I didn't really change anything besides this one thing just to demonstrate you would change as much as you wanted. However, for the purposes of this video, and I needed to be able to win within a reasonable amount of time, I shrunk everything down to size 5. It's all the same stuff as here. It's just an abridged version where I just deleted 20 of the last 20 of everything and changed the array size. I've created a variable for a char pointer, which is just a C-style string. So basically this is just a string variable, but it's a C-style string. I could have just used the word string. So I could have just done something like this, string. In fact, maybe I'll just do that below so you can see. String, I can't remember if that's actually uppercase here. I haven't used string. It's been a while since I've coded with the string. I try and remember if it's uppercase or not. But string, and you would do current word n equals, you know, whatever the word is. And you would just have to do that. String is a built-in type within Arduino, so you can do that fine. This is more or less just I'm kind of going off of C-style coding a little bit. Arduino is based on C and C++, and I just mix it up. So this is a char pointer, which is a string, a C-style string. This variable here is just representing the round number. It keeps track of the rounds that you're on. This code is associated with, well, this is the time limit. I've got it set at 25 seconds because 25,000 milliseconds, 25 seconds. And the start time just set to 0. These are both set as long. A lot of times I'll set these as on-sign long. It just gives you a little more leeway because long can be negative and positive, and I really have no reason for these to be negative if they're time. They're never going to be negative time. So typically you would make these on-sign long. The reason I didn't is simply for the fact of just to show you it doesn't fully matter because I'm never going to reach the limits of long anyway. But theoretically, by not making it on-signed, I've halved the time that I can go up to. Whereas if I make it on-signed, I basically take anything that would have been negative, any values that I could have went in the negative direction, they just add that to the positive end for me. So if you were dealing with numbers that were going to be huge, you would make it on-signed because you know time never goes negative. But I didn't do it because it's not required for this. This is just a variable to keep track of the number of hints that have been given because I only give 3 hints and then I cycle back. So that's just to keep track of that. Again, you can feel free to read the comments afterwards if you want to pause the video or anything like that. You might be wondering what this style of comment is. This is just another one of the many ways to make inline comments using Doxygen style commenting. So that, and there's different ways to do it. I could do 3 forward slashes as well. I could do this style. There's lots of different ways. I mix it up constantly. Again, if you're making code for production, don't mix it up. You need to be consistent with your coding and always maintain it the same. And that's probably going to be dictated by the company you're working for and their coding style. But for educational purposes, I find it good to mix it up. That way you can learn the different styles out there and you become more familiar. So I do that on purpose. But obviously, if you're doing code for production or passing it in, make sure it's consistent. And then I've just got regular inline comments here. These are some timing variables. This was code that I took away. But these are some timing variables that just allow me to use non-blocking code. So I've tried to eliminate as many delay functions as I can. I don't like delay functions. They're blocking code. They stop the program from running. And when I've got like a lot of different things going on, like in this case with the LED flashing, the button presses, the LCD screen, the timer, all that sort of stuff, I want as limited amount of blocking code as possible. So I often use time functionality to accomplish that. This is the melody codes associated with the Jeopardy theme song, the durations that each note would be played for. Again, this is code that I got off of, did I put his name up here? Yeah, off of Tom. And you can go to that website and check it out if you want. This is just the melody length. I take the size of the melody, which is the array here, divide by the size of one of the individual elements, and it gives me the melody length, which I use in a for loop. I added this Boolean flag is correct answer. This is how I solved the issue with when I was pressing the button at the last minute and it said correct, but then it still went game over. This was a simple fix to that, adding this Boolean flag. I'll show you how it's used in the code. There's probably more elegant ways to fix the code without needing this flag. I would have had to just do some revamping of the code, but I got a quick simple fix with this Boolean flag, so it works for the purposes that I need. In the setup, I'll try to get a little quicker because I know some long in the tooth again. So in the setup, I set up my serial communication, set up all my pin modes. So I set up both buttons using, for one of the buttons, the hint button, I use an input pull-up. So I'm using the internal pull-up resistor with a microcontroller, the 20 kilo ohm pull-up resistor, and that is because, why am I doing that? That is because on the little circuit I made for the hint button, there's no room to put a resistor on this little tiny circuit board, so I need to rely on the internal pull-up resistor. Whereas with this button, I already had a physical pull-up resistor, so this resistor is plugged into the power rail, but this one didn't. So I need to actually use the internal pull-up resistor via software, and this one I didn't. So it wouldn't have mattered if I did it for both. It just means there's more resistance. Those setting up my buttons as pull-ups, or as inputs. Set up my buzzer pin and my motor pin as an output. That's the vibration motor. Set up all my the RGB pins, the red, green, and blue LED pins as outputs, and then I display heads-up game to the on the LCD screen, setting up the LCD screen with the dimensions of 16 columns by 2 rows, and I just delay for 2 seconds. Basically, show the intro message for 2 seconds. Then I'm going to generate a random order. So I'm going to take the words and call this generate random order function, which makes it so that the words are always in a different order. That way the game is actually fun and dynamic. And every time you start the game, it's not like the order. Oh yeah, the first one is moose, the second one is beaver. That would be no fun. So that generates a random order, and then I call this function to show start sequence. We might as well jump right to those actually, and just show what those do. So random order. So it's under my helper utility functions. Again, I'm using Doxygen style commenting here with the tags. So void generate random order. So generate random order is a function that takes no parameters and it returns nothing. And right away we just call the random seed function, which this is whenever you're dealing with randomness in programming. Programming isn't really random, it's pseudo-random. And so oftentimes what you'll need to do is you'll need to seed your random generator in order that you don't always get the same sequence of randomness. It might be random. They might give us a random ordering of words, but they're always going to be the same random order. It's always going to be moose, beaver, dog in that same order. It's going to be random from the array ordering, but it's always going to be the same. So you're always going to want to do a random seed. Seed your random generator in order to get actual randomness. And the typical, one of the common ways to do that is to use an analog read off of just a pin. So I'm doing an analog read off of pin 0, so the analog 0 pin. And then I'm using that as my seed. I could have just put a number in here as well. If you're ever testing your code and you want to verify something, you'll put in a physical number in here. That way you'll seed with a random, with a number, but you'll always get the same order. So that's good for testing, but not good for gameplay. And then we use this for loop to iterate through whatever the array size is. Typically that'd be 25 or whatever you want it to be. In my case, I made it 5 for the video. So I'm just iterating through all the words. So this outer loop, that's all that it's doing, is iterating through all your words, because you're going to make them all random. I've got a couple local variables, an int variable num, boolean variable unique, and then I use a do while loop. So I'm always going to execute this at least once. And basically, I'm going to come in here and assign my boolean variable to true. I'm going to call the random function of the array size, so it's going to give me a random value from 0 up to the array size, not including the array size, which is good because we don't want an out of bounds error. And we assign that to num. And then we use this other for loop to, I know I'm getting long here, we use this other for loop to essentially assign that value that we just got to our sequence. So this is the sequence. This sequence array represents the order that the words are going to be in that we're going to output for the user, the player rather. So we're randomly grabbing, we're randomly assigning something to the sequence, and that's what we're going to use to grab the words in a random order. And we're just going to do this while not unique. So this is going to go through the whole thing and keep grabbing if we come across something, because again, it's by chance that we're going to get random. This isn't going to just run exactly 25 times, let's say, if that's the array size. It's going to run more because it's going to get times that we don't grab a unique number, that we generate the same random number, and we've already grabbed that. So that's all this does. I don't want to get too much into the weeds of this. This code here is explained in the general circuit guide. And then the show start sequence, this basically just outputs some stuff to the LCD screen at the start of the game. Get ready, waits 2 seconds, and then does a countdown. using the actual delay function. So I made a big deal about saying I don't like blocking code. Well, there's a couple exceptions. Blocking code in setup is fine because it's only happening once. It's not happening constantly in the loop. So I used it here to do a countdown of every second using just a delay of a second. That's a common case, is to use delays in setup where it's only happening once, and so it's not affecting the operation of the program, so it's not really blocking things. I know right now nothing else needs to happen while I'm waiting that second. This is just to give me a countdown from 3 to 1. Well, technically it doesn't show 3, 2, 1, and then we output start for 1 second, and then we're done. So that just happens once at the start of the game. And then, so we do that. We generate our random order, basically out of our array. Where's the array of words? Out of the array of words, we just generate them in a random order, and then we output that starting sequence. Then in the loop, the outer loop basically iterates through every word. So this outer for loop iterates through every word in the array. So, up to array size. So we're going through all the words so that we get through the game. And after we're done that, assuming you were successful, we're going to call the winner function, which just basically, plays the Mario theme and flashes the green LED and just lets you know, oh, you won. Amazing. That's the outer loop. We're just going through the words. Then we have this inner loop, and this is controlling getting our user input from the game, doing our countdown, and basically checking, just waiting for user input. Like they're pressing the hint button, are they guessing correctly? That's what that's doing. So the outer loop is going through all the words. The inner loop is dealing with user input and like the countdown, the timing, all that. So, okay. So with the inner loop, we come in, we immediately check our words array, which is, our array made up of, our 25 words, or in my case, 5 words. And then I'm looking at the index of the sequence sub I. So again, start off with sequence sub I, the first element in the sequence array. Remember, the sequence array is the one where my words are stored in some random order. I'm grabbing from the words array, the non-random order array, I'm grabbing this word. And then I'm assigning that to current word. So this is going to give me the current word based on the first word that's in the sequence, that random sequence. I clear the LCD screen. I make the round number I plus 0 or I plus 1. Why? Well, because I don't want to say round 0. That's just not what we do. So we count from 0 as computer programmers, but I want to output round 1, not round 0. So that's what's happening here. And then I just output that to the LCD screen, the round number, and then the word, the current word. Then I grab the current time from the computer since the last reset using the millis function. And then while the current time, I grab it again, I'm constantly grabbing the current time here. While the current time minus the start time that I grabbed up here, while that duration is less than the time limit, I'm going to keep, having the user try to guess while the time limit isn't up. That's what's happening here. I'm stuck in this loop until the time limit runs out, or till the user guesses correctly. Then here's that is correct guess Boolean flag. I set it false every time I come in the loop, and I'm only going to set it true when I correctly guess. That's the way I solve that issue where, again, if I press the button at the very last minute, it said correct, but then still gave me game over. I fixed it with this Boolean flag. So again, when I'm in this loop, I'm grabbing the current time the same way I did up here, start time. I'm grabbing the current time, and again, it's an on-sign long. Again, in this case, it doesn't really need to be on-signed, but it is best practice to make it on-signed. There's no reason for time to be signed. It's never going to be negative. So I grab the current time using the millis function again. Skip this code. I was doing something different with this. And then I call the shutdown function. The show countdown function. That's just showing the countdown, from 25, 24. That's all that's doing. We'll look at that in a minute. And then I'm checking to see if the hint button has been pressed. So if digital read of hint button equals low, because it's an active low, remember it's being pulled high by default, so it goes low if it's pressed. If it's low, and, I'm using the Boolean and here, and enough time has passed, so the current time minus the last hint time, I'm using time functionality, not a delay, if enough time has passed, a second, since the last hint, then I get to come in here. So, and then I'm just updating the last hint time to the current time, and and providing the hint. So I'm calling the provide hint function, passing in I as the current hint. And the reason being is because depending on the button press and how many hints they've used so far, I'm showing a different hint. Remember, I'm showing the category the first time, the first letter, and then the scrambled version. And then cycling back just to showing the word. So that's all dealing with the hint button if it's been pressed and if a certain amount of time has passed, particularly 1 second. And again, this is all just using time functionality as opposed to a delay. So that's kind of just like a debounce thing. Then I have the game button. So there's no need for a debounce. You press it and then you're not going to press it again right away that quick. So again, I'm doing a digital read of the game button. Same thing, it's active low. And if I've pressed that, that means I had the correct answer. I only pressed it if I knew the answer. So I'm going to go to the correct answer function and then break out of the loop. Before the issue, just in case you're curious what was happening, when I was pressing the game button, the black button, and getting the correct answer right before the time ran out, and then I still had a game over, what was happening is I was breaking out of the loop, like I should have here, when I got the correct answer, but then I was coming back here, and I wasn't going in the loop this time because I didn't meet this criteria, but I immediately came down here and went, if the current time minus the start time was greater than or equal to the time limit, which it was. I mean, I literally just came to the last second, right? So this will be true. I was going game over. So no matter what, if I got it the last second, I technically did correct answer, broke out of the loop, but then I immediately came here. As soon as I broke out of the loop, I came here, and this condition was true. The current time that I poll using the millisecond minus the start time, which hadn't changed, it was caught up here before the loop. This time was in fact greater than the time limit because again I waited till the last minute, so I ended up doing game over. That's what was happening. So I simply added this extra qualifier by saying if this is true and is not correct answer, which it by default isn't, because remember I set it to false at the start of the game and as soon as you enter the loop, then I wouldn't come in here. So I only come in here if it's not correct answer. And this, even though it's set to false right away, when I go to the correct answer function, I set it to true. So it would be set to true here, I wouldn't come in, and then the next time it's set to false, this condition no longer is true. So there you go. But otherwise I'd call game over. If we ran out of time, if I passed this and this condition suddenly was no longer true, this wasn't less than the time limit, I would have came out of here and game over. Otherwise, I won. So now let's look at the functions. If, and again, I understand I'm kind of all over the place, kind of quickly going through this. If you have questions, post them on the forum. I'm trying to get through this somewhat quick and still explain a little bit. So when you come in the correct answer function, takes no parameters, returns nothing. Again, I got my Doxygen style comments. This just handles the correct answer. What do I do if I get a correct answer? I make sure the vibrator is not going, the vibrating motor is off, because it might have just been on, especially if I let time run right down. So I shut that off. I output to the LCD screen correct. This isn't really necessary, this spacing, but sometimes, because I especially consider I just cleared, sometimes I wouldn't use the clear. I would just not have the clear, because sometimes doing LCD.clear a lot of times, especially when it's really quick, causes flickering. So sometimes it's better just to write over, like I would put the set cursor function here, LCD.setCursor, and just put wherever I wanted this to land, 0, 0, and just rewrite the stuff, and always do padding up to the full length of a row. That's sometimes better than using the clear. I chose not to do that in this game as much, or at least I don't think I did in many spots. I just constantly use the clear. It seemed to work. It didn't cause much flickering. But if you find that you're getting a lot of flickering, depending on your code and how fast everything's running or what you're doing, sometimes it's better to not use LCD.clear and instead just constantly set your position of your cursor to where you need to write, and then just write over everything by padding up to the length of your row. If that's not clear, feel free to ask questions on the forum, and I'll explain that in more detail. And anyway, so I output correct. I call the play correct guess music, which is just that Mario theme, and then I reset the number of hints given to 0. And yeah, just that way when I restart, I'm back to 0. So my first hint is going to show the category. Originally I just had a buzzer going. I think when I first did this code, I just, had the buzzer go high and low, but that was before the Mario theme. And then here's my savior for that button issue I had, is I set the is correct answer, the Boolean flag, to true when I have the correct answer. The game over function. Again, I set the vibration motor to false. Again, I do that in the correct answer. Again, if the motor was just vibrating horrifically, which it would have been because time would have been running out, and I didn't guess anything, I just shut that off. And then I just output to the screen that game over on the first row, and then the score on the second row with the round number. The score is what round number I made it to. And again, the round number -1, because the round number would have been incremented for the round I was currently on, but I don't want to give them that score. They didn't get that, so I minus that from them. They only get the scores that the rounds they completed. Again, as I said before, because I'm setting the cursor location before both of these outputs, and then the output I'm padding with zeros, this LCD.clear actually doesn't need to be there. It's not doing. I'm clearing, and then I'm setting the position, and I'm writing something that even if there was stuff on the first row, I'm going to cover it over anyway. So this LCD clear is doing no work. So you could easily just comment it out, and it'd be the same effect. Then I set, so game over, I call this set RGB function that I've created to just display red. So RGB, so the G and the B, 0, full red. And then I play the Mario Death Lava tune. Again, just a familiar sound of defeat from my childhood and perhaps yours. And then, yeah, I stick myself in a forever loop. While 1, which is while true, I'm just going to call the flash RGB LED, which is going to flash red. So it went red at first when the game was over, and then I flashed red. And I only flashed 5 times. I could theoretically make that flash indefinitely by taking away the if statement for 5 times, but that's up to you. But more or less important, I just stop the game until the user resets the Arduino or shuts it off. In the winner function, I do similar thing, but I'm a little more positive. Instead of I shut off the vibration motor, and although it wouldn't have been on technically, but I have it shut off anyway just for clarity. But again, if I won, that means, well, actually, correction, if I could have won right on the wire, so the timer could have been going really close to 0, in which case the vibration motor would be going. So I need to shut that off. I clear the LCD screen, and then I output you win. I could have done this on 2 lines, but I did it all in one. And then I play the Mario winning tune, and then I stick myself in another forever loop, the same as I did up here. But up there I had flashed red, now I'm flashing green because you won. It's good. Everything's happy. For the hint functions, I'm at brief, it provides a hint for the current word, the word index at param, which represents the parameter here, the index of the current word in the sequence. So I pass in the current word, the index of the current word in the sequence, provide hint for that word, and then I start off by clearing the LCD screen, printing the word hint, and then depending on how many hints I've already given, we're going to do something different. So again, I use a if-else-if ladder here. So if number of hints equals 0, well then I'm going to print to the LCD screen the categories of the index of sequence sub-word index. So again, all these arrays, the categories arrays, matches the indexing of the sequence array. So I output the category that's associated with this word. If you've already had 1 hint, now the number of hints that have been given is 1 so far, then I'm going to output the sequence words, the words of sequence sub-word index sub-0. I'm going to output the first letter of the word. This is hard to say, but you can pause the video and look over the code. I'm outputting the first character or the first letter of the word. And then if you've been given 2 hints already, meaning you're on your 3rd hint, number of hints equals 2, I'm going to, and again I'm using the string here, not a char pointer like I did before, just to mix it up. I'm going to create a scrambled word. So scrambled word equals, I call a function that I've created called scrambled word that takes in the original word, words at sequence subword index. So this is the original word it takes in, it scrambles it up, and it returns a scrambled version of the word, which I assign to this string variable, which I then just call here. So scrambled word is a variable type string. I throw it into lcd.print, and I print that scrambled word. Else, meaning if they have been given, if it's the first hint, second hint, or third hint, if it's been more than that, well, then that means that I want to cycle back. They've pressed the button again, and I want to cycle back just to showing them the word that they're guessing. So again, I do the same thing I did originally when I show the word. I just output the round number and the current word, and I decrement the number of hints guessed to -1. If I just made it go to 0, when I came in here, I would jump to this spot, because if I make it go to 0, immediately after this code, that's when I increment number of hints given. So if I made this go to 0, it would instantly get incremented to 1, and when I came back in here, I would never show the category again after I cycled through once. I would always just show the first letter of the word, and then the scrambled word, and then come back to the actual word. So I set it to -1. That way, when it immediately gets incremented here, I'll get to go through all the hints again, including the category. In the scrambled word, as you can see here, this function takes a string as an input and randomly rearranges its characters to produce a scrambled version. For example, if I had the word rabbit, it would become batrib or artbib, etc. All kinds of different options. Just any scrambled version of this word. So again, we take in a parameter of type string, and we return a string. And when we take in that word parameter, we assign it to the variable string scrambled. And then we go through, use a for loop to iterate through the length of that word, whatever the length is, -1. So we don't have an index out of bounds error or anything. And yeah, so as long as, so that's what we initialize I to be, the length -1, because we're starting at that end. And as long as I is greater than 0, we're going to decrement I. And all we're doing is we're generating a random index within the array of 0 up to I, using the random function and passing in I. And we assign that to j. And then we do the standard algorithm here where we do a swap by creating a temporary variable, assigning, in this case, scrambled sub I to char temp, because again, it's just a letter. Scrambled sub I is a letter, because, you know, a string is like an array of chars. So we assign that to temp, and then we assign scrambled sub j to scrambled sub I, which we just assigned to char, and then finally we assign temp back to j. So this swapping mechanism is fairly common in programming, so you're probably familiar with that. And then we return that scrambled word. So that's all we're doing. This function just scrambles up a word and returns it. And show start sequence, show countdown. I'm going to start speeding up the video here. I do apologize. Basically, we get the elapsed time by taking the current time using milliseconds, minusing the start time, which I calculated way above in the code when we first started the loop. We assign that to elapsed time. Again, it's long. It should be unsigned long. That doesn't really matter. And we then find out the time remaining by taking the time limit, which I've got set at 25 seconds, 25,000, because milliseconds, minus the elapsed time, whatever the current, and then I divide by 1,000, because again, this is going to be in milliseconds, this is going to be in milliseconds, so I take this duration, divide by 1,000, it gives me the time remaining. And then I just output that to the LCD screen. Again, this is just using padding, so I don't have to do clear. You'll see that I have commented out clear here, and that's what's uploaded on the microcontroller. So I didn't need to have clear because I'm setting my position to the second row, so left justified on the second row. I'm outputting the time remaining, and then I pad to the end of the row. This is a really elegant, I'll just mention it. I found this on Stack Overflow or Google or something, I can't remember. It's a really elegant way of doing it, I found, of transitioning the color all in kind of one line. And I was going to explain it because it's just done really nice. And if you pause the video, you'll be able to see it fairly easily. But in the interest of simplicity, I just went with direct mapping. So I'm really not using the blue at all in this case. I'm transitioning from green, when the timer first starts to red when the time is running out. So I didn't need blue at all. When I set my RGB color, I'm just passing in red, green, and 0. I have no blue mapping. But the way I'm doing is I'm just, for my red intensity, I'm just using the map function. I'm taking whatever the time is remaining, which I know is going to be between 0 and the time limit divided by 1,000, because again, this is in milliseconds. And I'm going to map that to 255 to 0. So again, if there's 0 if time remaining is 0, well, I want full red, because that means you're about to run out of time. I want that full red. Whereas if time remaining is full, like 25 seconds left, well, I want the red to be 0. And the opposite is true for green. If time remaining is 0, well, I want, correction, let me see here, yeah, if time remaining is 0, I want 0 green, again, because I want full red. But if the time remaining is full, I want full green. I might have said that backwards up here in red. Again, if I have 0 time remaining, I want full red. If I have lots of time remaining, I want 0 red. For green, if I have 0 time remaining, again, I want 0 green, because I want it to be red. Whereas if I have lots of time remaining, I want full green. So sorry, I might have confused you guys there. But basically, I want it to be green if there's lots of time left, red otherwise. At one point, I was trying to go through all the colors of the rainbow, Roy G. Biv. So I was using the blue, and I just didn't like how it looked. And I like the concept of going from green to red. So I took this out, but you could feel free to play with the colors as you want. Then basically, if the elapsed time is greater than the time limit times 80% or times 0.8, then if that's true, if it's greater than the time limit times 0.8, basically if you've only got 20% of the time left, then I'm doing a digital write of high to the vibration motor. I'm going to provide the player with haptic feedback via vibration. Else, meaning you have more time left than than 20%, then you're going to turn the motor off. And then finally, this is all still in the countdown, show countdown function. I'm going to play the Jeopardy note. So I'm have the buzzer indicate the time is almost up using some universally known da 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 da. Well, at least from my generation. I'm 40 years old, so might be older than some of the people watching this video. I'll just jump right to the Jeopardy stuff. Actually, so I'll just show the light again. I commented this out originally. I had created the function just to flash green LED because that's what I was doing. And then I'm like, oh, I should flash the red LED. And then I'm like, okay, well, I don't want two functions called flash green LED and flash red LED. So instead, I just created a function that flashes the RGB LED in a specified color 5 times. And the color was going to be determined by parameters. I was going to pass in the intensity of red, green, and blue. Again, I won't go through this. I'll try to be a little quicker. Flash count, just how many times I want to flash. I use static. I'm using static functions, so they only happen once. Basically, if you want to look up what static functions do, it's when you come into the code, into a function, they only initialize once. So every time I come into the flash RGB, flash count will be 0 the first time I come in and won't keep changing to 0. So it'll persist for the time of the function. I'm using time functionality instead of delays, so that's what this code is. And that's all what this is, just using timing functionality. I've got if flash count is less than 5, because that's all I want to flash is 5 times. I'm going to go if is on, based on my Boolean flag here. If it's on, I want to turn the LED off, and then toggle the state to turn it off, and then increment flash count. So that way next time I come on, it'll be off, and I'll go to else. And I'll output I'll call the set RGB function, passing in the red intensity, the green intensity, the blue intensity, which are the same parameters that got passed into this flash RGB LED function. And then I'm going to turn is on to true. So basically, I'm just going to toggle back and forth between going in the if statement, the else statement, the if statement, and the else statement. I'm going to do that 5 times. If I didn't want, if I wanted the flash to happen inevitably, correction, if I wanted to have the flash just happen forever, not just a number of times, but the whole time that the function was after you lost, I wanted it to flash red forever, not just 5 times, or after you won, I wanted it to flash green. however many times, I could just take away the if flash count is less than 5. And I guess I don't need flash count, although that could stay. But I could just take that away, and then it'll flash forever. I might as well just show that too in a second. I'll just re-upload the code. Oh, actually, you know what? I'm uploading the code, but the USB isn't plugged in because it was plugged into an external power supply. So while that's uploading, I'm just gonna keep going on and explain what's happening. So the set RGB color, again, this is just like a set color function I've named before. In this case, I just named it specifically set RGB. You pass in the 3 colors, and you do your analog writes to those particular pins. Just make sure we upload the code properly. Oh, that's what's happening. I forgot to comment that out. So yeah, no need to increment flash count if I've commented it out. So that's done compiling, uploading, and done uploading. So we'll see, once we lose here, we'll see this flash forever. So we got game over, score 0, 1, 2, 3, 4, 5, and 6. So once it hits your 6th flash, you know that it's just going to flash forever when you lose. Oh, I deleted the wrong code. Well, that's no good. Okay, my apologies. This will just take a second. I guess I meant to delete the other code. I thought I was deleting the original circuit code, but I didn't. So, but there you go. So we're back to where we were. So again, just by taking that out, you can make it flash indefinitely. So let's go. I'm getting some text, so I'm just going to have to speed this up again. So the sound functions, I think I've explained those in previous videos. There's lots of documentation on that. I'm probably not going to explain it too much more here because we're running out of time. But essentially I'm using this play Jeopardy function. I've modified it a little bit from what I found from Tom, the guy I referenced at the start. Just to use, he had a lot more delays in here, and I just kind of replaced the delays with time functionality. Again, I try to avoid delays, and I'd rather use time functionality just you know, for the sake of not having blocking code. But essentially, you can look at his thing and you'll see his code and mine are fairly similar here. It essentially just uses notes that were declared up at the start. Uses these notes and these durations and this melody length in order to achieve the desired effect of the song. So where am I here? So that's what that function does. All the play functions essentially work the same. Again, this just plays the stage ending theme. So if you got the correct guess, I just made the local variables for the melodies. Again, this stuff I found all on, I might have changed some of the codes slightly, did the comments, and maybe change some of the functionality just to not use delays as much, although I think I did keep the delays in this code. But a lot of this is found on GitHub. There's tons of Mario and other sort of themes on GitHub. So any tweaking I've done from it, it's just minor, it's just aesthetics and stuff like that. But really, the melody is determined on someone's taking the time to figure out the frequencies in the melody, someone who's musically inclined, unlike myself. And the durations, I can't remember if I played with the durations or not. I made this code originally a month ago. I think I did adjust some of the durations just because I found it sounded better at this speed, but that's something you would tweak, and it would sound better if you know, obviously, if you change the length of the durations. Still keeping them in the same amount. You can see that this last duration is twice as much, so adjust them proportionally relative to each other. Use this for loop again to output the sound. This is kind of something I just times by. Again, if you change this, it'll change the sound. Add a brief pause. That just made the melody, instead of going, I did a brief pause because otherwise I immediately went back into the Jeopardy melody and it sounded weird, so just a little pause there, a little delay. The playing Mario tune, same thing. These melodies, a lot of them are very similar, by the way, if you look up, 660. But again, this stuff is all on GitHub, the melodies, the durations. Again, I'm not really musically inclined, so if you are, you might be able to see some of this better. I just know that tweaking them sometimes makes it sound better, but I don't know why. So, not really musically inclined. But same functionality happening in all of them, using the for loops, turning the buzzer on and off, using the no tone. So again, if you're familiar with the tone function, again, it accepts 3 parameters. The buzzer pin, the pin you want to output the tone on, the frequency, which I'm using melody sub I, like based on the for loop, so one of these frequencies at the time, frequency, and the third parameter is optional. It's the duration you want to play for. In which case you don't actually need to use the no tone function. If you don't include the third parameter, you have to stop the tone by calling no tone. I've explained that all in a previous video, so I'm not going to go over too much here. But if you have any questions, post them on the forum. I'll be happy to go over some of this code with you. And this is finally the play lava thing. That's the code in a nutshell. Again, I apologize that these videos are so long. I'm not a content creator by any means. I'm just doing this for the final project for Comp 444. And I'm finding out that I would have not made any money as a content creator. But I do appreciate you sticking with me. And on that note, we might as well end with a quick demo. And again, just so you know what's happening. Heads up game, get ready. We do a quick countdown. 3, 2, 1. Start the game. We have the Jeopardy sound. We have the round number, the word that we're trying to guess, the countdown. The RGB LED, by the way, is changing from green to red as the timer runs out. We can cycle through the hints and then come back to the word. Haptic feedback when we're getting really close to timeout. You press that button when you think you've got the correct word. Again, cycle through the hints. The first hint's always going to be the category. The second hint's always going to be the first letter of the word you're trying to guess. Third hint is going to be an anagram, like a scrambled version of the word. And then we're going to cycle back to the word. And we're going to keep cycling through those hints. I only provide 3 hints. If you haven't got after 3 hints, you don't deserve to win. I provide haptic feedback as your time is running out. We play a nice little Mario theme, a stage clear theme, if you get a correct guess. And if you win the game, we play Mario theme as well. If you win the game, the RGB LED flashes, well, now in forever. It'll just flash on and off green. If you lose the game, it would flash red forever, and it would play the losing soundtrack. And again, we can cycle through the hints. We can increase the volume. Turn the volume off. Turn the volume back up. We can adjust the LCD screen. And I won. Excellent. And that would, I stopped it, but that started to flash green. That would have flashed forever. And again, if I lose, I'll just end as on the losing soundtrack. And I'll shut off the video. So again, if I go through the hints, animal, I still don't know what it is. Begins with an M. Lots of animals begin with an M. Monkey? I don't know. Siamone? Still have no idea. And, this would be up against my forehead, so I wouldn't be able to see this. Yeah. We'll let the time run out. We can see that the time's running out. Haptic feedback.